I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics,
medicine,
nature,
or
space, time,
the brain,
life, the universe.
This week's social media, or should that more accurately be anti-social media. We're exploring how this exploding trend is influencing our opinions, might be addictive for some, but might also provide us with new ways to spot people with mental and other illnesses much faster than a doctor can.
Plus, in the news, a breakthrough in treating the brain condition Huntington's disease. A dinosaur parasite is found fossilised in amber, and it's 50 years since scientists first heard spooky radio signals from deep space. But what were they? I'm Georgia Mills.
I'm Chris Smith, and this is The Naked Scientists.
The Naked Scientists podcast is powered by ukfast.co.uk.
First, our top story this week. A DNA-based drug that can penetrate brain cells might be about to revolutionise the treatment of the degenerative condition Huntington's disease. The success of a small initial trial of the agent, currently called Ionis HTT-RX, has prompted the pharmaceutical company Roche to license the drug and take it forward. Chris spoke with UCL researcher Ed Wild, one of the team testing this new agent.
For the first time, we have the results of a clinical trial that is aimed at tackling the cause of Huntington's disease, which is a protein called huntingtin. And we have injected a drug into the spinal fluid of patients with early Huntington's disease and shown that we have successfully been able to reduce the amount of the toxic protein that is present in the nervous system.
Now, people with Huntington's, what symptoms do they display? How does it affect them?
It's a relentlessly progressive disease. In early adult life, typically in a patient's 30s or 40s, they will develop subtle personality changes, things like being more irritable, having problems concentrating at work, having a shorter fuse, anxiety, depression, and then a bit of fidgetiness. And the symptoms will then slowly progress over 10 or 20 years until a person loses the ability to walk, to control their limbs, it loses the ability to speak and swallow. And unfortunately, eventually, all patients with Huntington's disease become completely disabled, and it is always fatal.
Who gets it?
It is a genetic disease. Many people with Huntington's disease know that the illness runs in their family. Each person with the disease has a 50% chance of giving it to each of their children. Somewhere between 5 and 10% of patients we see in our clinic, though, didn't know that Huntington's disease existed in their family until they're diagnosed after clinical investigations and a genetic test.
And what is the abnormal gene doing to these people to make them have this disease?
Everyone has 2 copies of the gene behind Huntington's disease, but in someone who's not going to get it, both genes are normal length. And at the beginning of the gene, there's a sequence of genetic letters, CAG, 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 and so on. If there are too many CAGs at the beginning of that gene, that is what results in a positive genetic test for Huntington's disease. And that gene is a recipe for a protein called huntingtin. If you have too many CAGs in your gene, the protein ends up a little bit too long and with too many building blocks called glutamine at the beginning of it. Essentially, that protein is poisonous to your neurons in the brain, and it builds up, it interferes with the functioning of neurons, and at some point it becomes too much and the neurons start to die.
And the new therapy that you trialled, how does that work?
The drug is called an antisense oligonucleotide, or ASO, and it is a synthetic DNA molecule. So what happens is that this synthetic DNA molecule is injected into the spinal fluid, and from there it enters neurons. It sticks to the message molecule that is intermediate between the gene and the protein. So the gene is a recipe for the protein, but before it makes the protein, the cell essentially makes a working copy of the gene. And that molecule, that so-called message molecule, is the one that is directly used to build the protein. So the drug molecule sticks to the message molecule, and the cell has built-in machinery for detecting when something has stuck to its message molecule. And when that happens, the cell's immediate reaction is to get rid of it. It essentially deletes the message molecule. And if you do that, then much less of the protein gets made.
Over what period of time was this given to the patients?
This was a pretty short trial, so 4 injections were given over a 4-month period. It was principally designed to ask the question of whether the injection of the drug was safe, was it well tolerated, and did any short-term safety issues arise. And the good news on that front is that in the 46 people in the trial, there were no significant safety issues identified from either the injection procedure or from the drug.
And did it make a difference to the levels of the huntingtin, the abnormal protein that would be there in these people?
It did, and that is why people in the Huntington's field and beyond are so excited about this preliminary announcement. What we found was that there were significant decreases in the level of the mutant huntingtin protein. This is not a cure for Huntington's disease. At the moment, we have no idea what this drug will do clinically. Will it slow the progression of Huntington's disease or not? We are going to need a much longer trial to test whether giving this drug in the long term slows the progression of Huntington's disease.
Definitely some work to watch there. That was Ed Wild from UCL.
Indeed, absolutely fantastic work and a really good reason to be optimistic. Now, dinosaurs have ruled the planet for hundreds of millions of years, but they weren't immune to being preyed upon themselves by parasites. And now scientists have discovered an ancient tick clinging to a 99-million-year-old dinosaur feather trapped inside a lump of fossilised tree resin. Georgia spoke with the discoverer, Ricardo Perez de la Fuente. He's from the Oxford Museum of Natural History.
We present the first direct evidence of a parasite-host relationship between ticks and feathered dinosaurs. We have a tick that is grasping a feathered dinosaur in Burmese amber, which is 99 million years old. We also have described additional ticks that belong to a new group of ticks, an extinct group of ticks that went extinct probably at the end of the Cretaceous. So those are the 2 main findings.
So I'm quite familiar with ticks that exist now. I have to take them off my dog when she's running through shrubberies. Is this tick similar to what we'd see today?
Yes.
What is it?
So actually that tick, it's an immature tick. It's not. It's about 1 millimeter in length, and it belongs to hard ticks. So the modern groups, whenever we think about the classic ticks, hard ticks are the ones that come to our mind, right? They have this shield-like structure at their backs that mostly protect them from when the host is trying to scratch them off, for instance, right? So the tick that is grasping the feather in the amber piece that we discovered and we described in this new paper is it's very similar to modern forms. Actually, the tick can be classified in an already described species. This is the first time that a tick is found in direct association with remains of its host.
Right, and this is pretty strong evidence then that dinosaurs had to deal with these pests as well. Then.
Yeah, absolutely, and that's actually the dream of paleontologists. 99% of the time, we are always working with possibilities, and we use the morphology of the fossils to try to infer ecologies and behaviors, right, of past organisms. But cases in which we can actually get access to direct evidence by direct association, those cases are very, very, very rare.
What must have happened for you to get this brilliant snapshot of, what was it, 99 million years ago?
Yes, so, amber is fossilized resin, it's sap from the trees that with the passing of time has hardened. But we can imagine that the feather with a tick grasping to it got detached from its feathered host and got in contact with some resin flow. We don't know if that happened actually on the trees or above the ground or at the forest floor and the floor level, because sometimes we can have resin becoming secreted high at the level of the branches of the trees. Sometimes, though, that resin falls on the ground. But that's overall the scenario that we can picture.
And how did you get hold of this amber?
We had private collectors donating part of their collections to museums, and through them we got to study them. And I mention this because actually nowadays Burmese amber can be purchased online. It's a good income source for the local sellers in Myanmar. So there are private collectors that are specialized in amber purchasing this material, and some of them, luckily, are interested in their collections to be studied by scientists. So this is one of it's had a happy ending. It's one of these strange cases in which private collectors broke the barrier between themselves and scientists, and because of that, we got a very fruitful work.
And I've got to ask, just because Jurassic Park is my favourite film, they
Oh,
find
really?
a mosquito in the amber and they bring dinosaurs back to life. Has anything you've got here enabled you to get any closer to the dream?
Very well put. So I would say that not in this case, unfortunately. Jurassic Park was based on a serious scientific study that had claimed to have extracted DNA from amber inclusions. But subsequent experiments were not able to replicate it. It must have been a contamination from modern DNA, right? Using modern techniques, there's actually no way we can extract decently preserved DNA from amber inclusions. It seems that DNA is a very fragile molecule and it degrades easily. So the message here is, okay, not at this particular moment of time, but we need to keep dreaming about Jurassic Park someday, perhaps.
Until then, though, we'll always have the film, of course. That was Ricardo Perez de la Fuente from Oxford University speaking with Georgia, and the research was published in Nature Communications.
Over the next 10 years or so, there's predictions that up to 1 billion genomes sequenced, and most of these are going to be sequenced in the healthcare setting.
In this month's Naked Genetics, we find out how advances in genomics are shaping the future of healthcare, from gene testing to gene editing. Plus, signposts for bees and an operatic gene of the month. Listen and download now at nakedscientist.com/genetics.
Still to come in the programme, we celebrate 50 years since scientists discovered strange regular radio signals coming from space. But what were they? And is spending time on social media bad for us?
If you'd like to get in touch with us on social media, it's at Naked Scientists. You can also find us on Facebook, or you can do it the old-fashioned way. It's chris@thenakedscientist.com. Now, here's a tough one to answer. Are the science papers that scientists publish getting harder to understand? William Thompson thinks they are.
We were 4 PhD students frustrated about reading different scientific texts. We had journal clubs together, and there was specifically one person that we were reading repeatedly that we thought was hard to read. We joked originally, has this person always been hard to read, or is this something which is developing as the ideas have developed? We realized we could quantify this, and as soon as we realized we could quantify it for one person, we realized we could apply the same tools and get a much larger corpus, which was over 700,000 scientific abstracts. We made a list of 123 highly cited journals from 12 different fields. Then we tried to quantify the readability. So, for example, the number of words per sentence and the number of syllables per word, and try to make an estimate about how hard it is to read.
What time frame did this span?
So the earliest article was 1881, but most of the scientific literature started to appear around 1960 that we could get our hands on, and then up to 2015.
And when you run the text from those abstracts through the analysers and ask it to score the language that's being used, what trend emerges?
We found a large downward trend in readability, and that means that texts are getting harder to read now compared to previously. We were surprised by how strong the trend was.
You looked at a whole raft of different journals, which means that you could consider different scientific disciplines. So are any disciplines particularly prone to this, or is it that all scientists across the board now have a tendency to over-complexification and use of long multisyllabic words where simple terms might actually be feasible instead?
I think the important take-home message was that all the fields we looked at were getting worse. There were some differences. For example, clinical medicine was the least worst, and molecular biology was the worst in one of the metrics. But I don't think the emphasis should be placed on that. I think the emphasis should be placed on all fields were getting worse.
How do you account for this?
With the data we had, we tried to explore two possible reasons. One of them was, did the number of authors impact the readability? Because the number of authors has been growing over time. You often see 4 or 5 authors on a paper today, where in 1960 it was 1 or 2. The number of authors does have an impact on the readability. So if there's more authors, it's generally less readable, but that doesn't explain the trend. So an additional hypothesis we had was that scientists may be drawing from an increasingly common vocabulary. We tried to see what were the 3,000 most common words that scientists use. Then we split this list of 3,000 words up into several categories to isolate a category we called general scientific jargon, and these words were on the increase. Scientists are drawing from this vocabulary of general scientific jargon.
Do you think it really matters, though, that some papers are a bit impenetrable? Because some people could argue, well, I'm a molecular biologist and it means something to me, and I don't really care that much if an astrophysicist can't read my molecular biology paper.
I'm very sympathetic to that view, but at the same time, this entire endeavor started when PhD students within the field of neuroscience were having a hard time reading some neuroscience. So it can hamper people within the subject itself. Then in a much wider context, science is not just for scientists. People should be able to use scientific knowledge to make society better. So if the wider parts of society cannot access papers such as scientific journalists or policymakers, if they're having a hard time interpreting or understanding scientific text, that's going to mean that science can't be used as effectively in a wider context.
And of course, here on The Naked Scientist, no science is too hard to understand. That was William Thomson. He's at the Karolinska Institute in Sweden, and he published that study in the journal eLife.
Now, Lewis Thomson is about to make us all feel a little bit sheepish for believing this myth conception.
On the 5th of July, 1996, Dolly the sheep was born. She'd been created by scientists at the University of Edinburgh. They took the DNA out of a cell from an adult sheep and inserted it into another sheep's egg cell, which had had the DNA taken out. They then implanted this egg cell into the uterus of another surrogate mother sheep. Dolly was the first mammal to have been produced by this cloning process and quickly became a celebrity. However, at the relatively young age of 6, she had already developed several health problems, including early onset arthritis and lung cancer. Sadly, she had to be put down. Concerns were raised about the possible link between cloning and early aging, and many people became convinced that Dolly's health problems were caused by her being a clone. If this turned out to be true, it would shatter the hope that cloning could pave the way to producing spare body parts with which we could repair ourselves later. But now, a new study suggests that this is a myth. A paper published last month by Nottingham University's Sandra Corr and her colleagues has revisited Dolly's health problems. Even though Dolly has been dead for almost 15 years, and all of the original reports of her arthritis have long since been lost, her skeleton is preserved in the National Museum of Scotland in Edinburgh. So, Corr and her team carried out a detailed radiological, X-ray, investigation of the remains of Dolly, as well as of her daughter Bonnie, who was born naturally, and of 2 other cloned sheep, Megan and Morag. They found that, although there was some arthritis in her elbows and knees, most of Dolly's joints were fine. In fact, there wasn't much of a difference between the skeletons of any of the cloned sheep or their offspring and that of a normal sheep skeleton. Most sheep develop some arthritis in their elbows or knees, as these are the joints which bear the most weight. Pregnancy also increases the risk of arthritis, and Dolly was the mother of 6 lambs. This suggests that Dolly's arthritis wasn't really anything to do with being a clone, but just a natural result of being a sheep, and in particular, a female sheep. As for the lung cancer, this is also, unfortunately, quite common in sheep. The lung cancer that Dolly had was a specific kind, and is actually caused by a virus called JSRV. Being a virus, it is infectious, and so if one sheep has it, others can get it, and all of those that have it are susceptible to getting lung cancer. Other sheep in Dolly's flock were diagnosed with the virus, and some of them died because of lung cancer. It's possible that as Dolly's flock had to be kept indoors for security reasons, there was an increased risk of the virus spreading, and so an increased risk of getting lung cancer. So it seems that Dolly's health problems were nothing to do with her being a clone. The original reports of her arthritis were exaggerated, and her lung cancer was caused by a virus, not by early ageing. Having said this, the jury is still out on whether or not there is a link between cloning and early ageing. The DNA of a clone will be older than the DNA of a naturally conceived animal, and this may cause problems in later life. So maybe you should hold off on trying to clone your pet, at least until scientists have looked into this a bit more.
That's a shame. All I really want for Christmas is hundreds of clones of my little dog Bounder. Thank you, Lewis. And if you have some suspicious sounding science you'd like scrutinised, send us an email at chris@thenakedscientist.com and we'll take a look.
Now, in 1967, a student at Cambridge University came across a series of strange pulsing signals that subsequently went on to transform the world of astronomy. What Jocelyn Bell Burnell had discovered were pulsars, small, dense, rapidly spinning stars that fire off a lighthouse-like beam of radio waves as they go round. Dame Jocelyn Bell Burnell, as she now is, returned to her old college, that's Murray Edwards in Cambridge recently, to mark 50 years since her discovery by delivering a celebratory lecture. Izzy Clark went along to listen.
At that point in time, Cambridge University had one computer. It occupied a room of about this size and it had less memory than your laptop. And that was for the whole university. Our data came out on paper chart, rolls and rolls and rolls of it, because we didn't have access to the computer. Perhaps just as well, because if we had had access to a computer with limited memory, we would not have programmed it to look for anything unexpected, like pulsars.
Have you had many interviews in a room named after yourself?
No, I've never, I think, even been in a room named after myself. So
we're here celebrating 50 years of your discovery of pulsars, and that was when you were here as a graduate student at the University of Cambridge. What were you initially working on?
This was in the field of radio astronomy, which was a fairly new young field at that stage. And what I was meant to be working on, and in fact what my thesis was actually on, was finding more quasars, quasi-stellar radio sources, which are extremely distant and quite puzzling radio-emitting objects.
It was whilst studying these radio-emitting quasars that Jocelyn came across a rather peculiar signal.
The first thing that came to my attention was that there was a bit of signal that didn't make sense. I'd got to the stage of recognising the quasars that I was meant to be seeing. I could see what I nicknamed it a bit of scruff. There was a 1/4 inch of this funny signal that I couldn't make sense of in 500 yards, 600 yards, something like that. So it wasn't very common, it wasn't very extensive. But because I was being extremely thorough and keen to understand exactly what this new telescope was delivering, I was trying to check out what this was. Finally turned out that this little bit of scruff was a string of pulses, a string of blips, about 1 1/3 seconds apart. This is what came in on the recorder. Blip, blip, missing, blip, blip. Well, first of all, nothing like that had been seen before, and nobody imagined that anything like that could exist. So it was really, really surprising, and we had to take quite a bit of time to convince ourselves that it really was a signal from outer space, from stars, and not some weird kind of interference that we hadn't dreamt of. So, for example, I remember wondering if it could be radar signals bouncing off the moon and into our radio telescope, or could there be a satellite in a funny orbit which mimicked the motion of the stars? It took us several weeks of really hard work. Then I found a second one. And a few weeks after that, I found a third and a fourth. So that really does begin to feel like a new kind of star. And then the question is, what on earth? Well, not on Earth. What in the universe could give that kind of signal? What kind of star is this? It's crazy.
This baffling finding was the first detection of a pulsar, also known as a neutron star due to its neutron-rich core. But how does a star give off this pulsing signal? Imagine a lighthouse with its 2 bright rotating beams that can be seen from miles away. Well, pulsars aren't too dissimilar. This astronomical object spins round with 2 beams of radiation shooting out from each pole.
We still don't fully understand how radio beams are formed, but the magnetic field, we're pretty certain, has something to do with it. And as this thing spins, if the beam sweeps across the Earth, you see a pulse. It turns out that these objects are small. They're only about 10 miles across. But they also are very, very dense, very compact, so they've got a lot of mass in them. So they've got 1,000 million tons of stuff in a bowl 10 miles across. If you take a thimble and squeeze the 7 billion people on Earth into that thimble, then it weighs the same as if it were filled with stuff from one of these stars. We now believe that it's the end product, a life after death, if you like, of a very big star which has done a catastrophic explosion, which has basically killed off the star, dispersed 95% of the stuff out into space. But the 5% in the centre, the core, has been squashed in the explosion and become one of these stars.
And a Nobel Prize was awarded, but it went to your supervisor. So how did you feel at the time?
I think at the time people expected me to be very angry, but I wasn't. One of my colleagues his wife heard the news, phoned him up at work, and he came steaming through to my office to tell me, and I think he expected to see me explode, and I didn't, because I'm also a political animal. There is no Nobel Prize in astronomy. There's not one in mathematics either. Something to do with Professor Nobel and women and other professors. So certain areas he wasn't going to leave his money to. And this was the first time the Physics Prize Committee had deemed astronomy to have enough physics in it to award the Physics Prize. So it was a huge, huge precedent. Quite proud that it was my stars that had convinced them, and knew that it was going to open the door for other astronomers, and a couple of dozen other astronomers have walked through that door subsequently. So yeah, it was very important.
And people, as they're listening to this, are tweeting #legend. And she is indeed Jocelyn Bell Burnell, recalling for Izzy Clark how she discovered pulsars 50 years ago this year.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
And now it's time for the main theme of the week, and that is social media. There's Twitter, Facebook, Instagram, YouTube. The internet is absolutely awash with ways for people to share ideas and views with their friends and strangers around the world. It's undoubtedly revolutionised many aspects of our lives. It's bringing people together, it's altering the way that news stories are broken, it's changing political landscapes, and the messages that are tweeted and spread and disseminated can reach global audiences in just minutes.
But is there a dark side to this new technology? The past couple of weeks have seen a number of people speaking out against social media, including one ex-Facebook employee who said it was creating tools that ripped apart the social fabric of how society works. So does social media affect our well-being? How much data are we really giving away? And can it influence our moods or even our beliefs?
Well, this week we're going to try and find out. And first we're asking if social media is affecting the way we think. Are social media bubbles, and we'll explain what those are in a minute, influencing elections, for example? And can Facebook even influence our mood? Cambridge University's Sander van der Linden is here, and he looks into this very thing. Sander, welcome to the programme. What's the scale of use of social media? For the average person out there, how likely are they to know someone else who's on social media?
I would say that the scale is massive. So around the world, globally, about 2 billion people are using social media. And perhaps what's even more interesting is that more and more people, significant majorities, are getting their news from social media websites. This is particularly true for young adults, but also at increasing rates for older people. So I think perhaps the real testament to your question is this. If you now ask someone, do you have a Facebook account, and they say no, you're probably going to be the odd one out.
In what way might this influence politics? The way news is spread and so on. How can this change what we've been doing for centuries?
Well, I think the new media environment is definitely changing the way that people engage with information. I think the big challenge is trying to understand how. So, for example, if you're asking, are echo chambers and filter bubbles and things like that influencing political behavior like voting, I think it's quite a complicated question.
What is a filter bubble?
So an echo chamber is, imagine sticking your head in a chamber and everybody's absolutely loving what you're saying and sort of reverberating, you're right, this is the right opinion to have. That's the idea of an echo chamber. And perhaps it's created by filter bubbles, which are based on Facebook's and other social media algorithms that tailor content based on your prior click behavior. So when you like something, when you read something, that goes into the algorithm that then selectively targets you with what they call ideological consistent content, so political content that you've looked at before. And that sort of deprives you from other stories and stories that go on the other side and in the other spectrum. And so that's what they call a filter bubble.
It feeds me what I want to hear.
Exactly.
And sort of cushions and buffers me away from people, views, perspectives that I might not be aligned with. So I then end up perhaps being fooled into the idea that everyone agrees with me.
That's exactly correct.
And in what way might that then influence an election?
People say that it did. The trick is, how do you quantify that in academic terms? And I think there's two problems. One, some studies suggest that perhaps people weren't exposed to as much fake news as we had previously imagined. And so the link to actually mobilizing people to vote is difficult to make in causal terms. But then other studies show that, in fact, and this is the real power of social media, it's often not the message itself, but the sharing of friends and sort of, friends of your friends that influence you and actually propel you to have a certain opinion or to vote one way or the other. And so I do think that it has an influence. I think the problem is trying to quantify exactly how much it's influencing public debate and voting behavior. But I do think there's reason to be concerned about it.
And this whole question about it might influence your mood because you're being fed certain things but not others. In what way could that work?
Well, there's some clever experiments, and in fact, some of these were done by Facebook employees where they actually manipulate the newsfeed. So what they would do, for example, is decrease the amount of positive content in your newsfeed or decrease the amount of negative content. And by positive or negative, I mean emotional content. And what they find is that when they decrease the amount of positive content, you feel less positive. And when they increase the amount of negative content, you feel more negative. And so in a way, they can actually regulate how you feel and respond to content. And I think that's actually quite important and something to think about.
That sounds quite dangerous.
It is. And other studies show that it works the same with targeting people with messages. So people don't know this, but you are being targeted online with messages based on your click behavior. And the aim of those messages is to get you to do something, click or something. And experiments have shown that just simply targeting messages based on a user's behavior works in a very concrete way, in that they can actually mobilize people to click on something. And so, as you said, that can be quite dangerous, depending on, of course, the purpose for which it is used. For example, influencing elections.
But could it be used for good as well? Presumably there's some good in this. If we can do bad things with it, we can equally well do good things.
That's absolutely right. Now we have the ability to mobilize millions of interconnected people for things that we might value in society. For example, the ALS Ice Bucket Challenge was an example of that. It was an unprecedented viral campaign where millions of people around the world donated to a particular cause. It's, in fact, a very low-cost way to connect people, to organize people independently. For example, to supply access to information or internet in parts of the world where they're deprived of certain resources. So I think people have the capacity to do amazing things online that previously wasn't possible.
Do we know whether or not something stands a good chance of doing very well on social media? Or is there almost like a formula that you could tell us where you say, well, look, if you do your tweets in this way or you craft your campaign like this, you'll get a much greater chance of it succeeding?
Yeah, and some of the research I looked at, well, what makes a campaign or a social cause go viral? And we looked at many, many different campaigns. And one of the things we distilled was that there is almost sort of like a formula, and we used the acronym SMART. It stands for social influence, moral imperative, effective reactions, and translational impact. So very briefly, social influence means campaigns are inherently social, so that have an element that allows people to connect together and join the bandwagon. Moral imperative means that the campaign is about something that people care about, maybe social injustice. Effective reactions, there's emotions, things that make people feel good or bad that tend to go viral more often. And then the last aspect is really about sustaining that viral impact, because when you look at most things that go viral, what comes up eventually must come down.
Now, I'm not after a cheeky free consult or anything here, Sander, but we do have our annual fundraiser coming up. So can you give us some tips, me and Georgia, so that when we run the next Naked Scientist fundraiser, we've got an absolute dynamite campaign?
I'll do my best. So the first aspect would be social influence. Now, in a way, you want to illustrate how many Good Samaritans are already contributing so that people can see how much is being contributed to the fundraiser. So that's good. That provides what we call social proof. And then you want to show that it's, a good cause, in a way, to make that contribution.
Well, hopefully that's obvious. I mean, it's Naked Scientist.
I was going to say, it's Naked Scientist, obvious, right? Effective reaction, so you want to make people feel good about their contribution. They're contributing to a good cause and feel good about it, that hopefully then, and this is sort of where you hope to cross the T, that they'll come back next year and donate again.
Well, let's hope so. I'll send you the bill if you're wrong. No, I'm just kidding. Sander van der Linden from Cambridge University, thank you very much.
We just discussed how social media might influence our mindset, but what about our individual well-being? And in particular, what about younger people, amongst whom it's extremely popular? Philip Powell is at the University of Sheffield. Hi, Philip. So thanks for joining us. Do we know what effect social media has on someone's well-being?
So the evidence on this is mixed, and the first thing to say is that social media can have positive effects on well-being by decreasing loneliness, providing sources of support for people, and even providing a venue for them to affirm their sense of self-worth by reviewing their profile. But what we have as well as that is a series of large representative national survey studies that have been carried out across different countries that show a significant negative relationship between the time spent on social networking and people's well-being. And we know that these effects are largely concentrated at the top end of use, so people that spend an excessive time on social media, which is normally defined as around greater than 2 hours per day. Some recent research by scholars at Oxford University has actually shown that a low to moderate amount of social media use can be beneficial, and they've termed this the Goldilocks effect.
Okay, so some use is good, but a lot of use is associated with negative things. But how do we know that people who are sort of less well aren't just more likely to spend hours and hours on social media because of this?
It's definitely a concern, and the majority of research is associational, that just shows a correlational relationship between social media use and lower well-being. There have been some studies that have looked how the two things may interact over time, so it's been shown that changes in social media use are associated with changes in well-being. But that still doesn't mean that the change in, for example, Facebook usage causes the change in well-being. It's possible that another variable may influence the two things independently. Now, in our own research, we've tried to overcome this by using sophisticated statistical techniques. They are used when we don't have experimental data, but we're able to use additional data that has a one-way effect on our outcomes. We can essentially estimate the association between social media use and this additional data, which was internet connection speeds from Ofcom. And by estimating the association between those two things and the strength of this association with well-being, we're able to derive as close to causal relationships as possible.
And this is still indicating that a lot of use is negative. So what kind of effects is it having on well-being, and do we have any ideas why?
These things include reduced life satisfaction, increased anxiety and depression, and reduced happiness. So these are things that can be distinguished but are generally related to one another. The method in which increased social media use may result in low well-being is likely to be multifactorial. It may involve, for example, instances of cyberbullying, negative comparisons with others, exposure to inappropriate content online, and also through its association with disruption to physical and healthy daily activities such as sleep and exercise and other positive activities for our well-being.
You mentioned cyberbullying there. So Facebook previously only allowed over 13-year-olds to use their site, but recently they've launched Messenger Kids, which is a service aimed just at preteens. So do we know about how social media affects young people in particular?
So the first thing to point out is often children under the age of consent are frequently using social networking sites already. In our own data, we found worse effects of social media use on well-being in those that were aged 13 and over, and not at those that were younger. And there are a number of reasons why this may be the case. So we also know from separate data that cyberbullying increases over time in the early teen years. And we also know that there are increased pressures on children and young people to fit in the teen years.
Social media is obviously a very broad term. There's lots of different types of social media and there's lots of different ways to use it. So do we know what kind of different effects different social media has?
There was a recent survey by the Royal Society for Public Health, 14 to 24-year-olds, and they had their participants rank the main social media platforms, so that's Facebook, Instagram, Snapchat, Twitter and YouTube, and they had them rank them on a range of health-related factors, including depression, body image, experience of bullying. And what they found is actually that YouTube came out as the most positive and Instagram was the most negative. And they don't actually elaborate on why that may be the case. But we could, for example, hypothesize that because Instagram is a platform that involves user-generated photos, and we know that idealized and filtered photos are particularly problematic for young people's well-being. The other thing to mention is there's been a distinction throughout the literature between passive and active use. And now passive use describes things like looking at people's profile pages and liking, whereas active use involves actively connecting and chatting with people. And it tends to be the passive use that is particularly problematic for well-being.
Do we know anything about how social media affects our ability to learn, I suppose specifically with children?
No, I think there's a positive research in this area, and this is something that we'd like to look into in the future.
It'd be interesting to see what that says, but it certainly makes procrastinating easier. What do we do about this? I mean, do we need to do anything?
So there are three main approaches we could take, and they're not all mutually exclusive. So the first is that we try to reduce or restrict the amount of time that children and young people, and maybe even adults, spend on social media. The Royal Society for Public Health has called for example, pop-up warnings on heavy usage on social media sites, and this is supported by a majority of young people that they surveyed. The second approach is that we focus on this idea of usage. So it's not amount of time per se, but it's what people are doing online. So we need to generate platforms for social media that encourage active use and discourage passive browsing of information and social comparison. And finally, there's the idea that's supported by places like the Education Policy Institute, that we actually have a duty to educate our young people in the safe use of social media and equip them with digital skills so they can cope with problematic behaviours online.
Many thanks. That's Phil Powell from Sheffield University.
So far, we've looked at how social media can affect us socially and politically, and also possibly impact on our well-being. Well, as we've discussed, more than 2 billion of us are using social media, or at least were in 2016. It's 20% more now. And Facebook has the highest number of active consumers. In fact, the average user spends nearly an hour on Facebook's suite of applications every day. But some people invest considerably more time than this and may even forego other pleasures in life to feed their habit. They may even complain that they feel physically unwell if they become separated from social media for any period of time. Might they therefore be considered addicted? Daria Kus is at Nottingham Trent University.
We have some research that has been conducted around the world which would suggest that social media use in some instances for some excessive users can indeed lead to the development of addiction-related symptoms. And these kinds of symptoms are relatively similar to symptoms that are experienced by substance abusers. These symptoms are related to tolerance, so needing to spend increased amounts of time using social media, withdrawal symptoms that occur when the person is trying to cut down on their social media use, so depressive symptoms, loneliness, irritability, moodiness, things like that. And I think the main criterion that really distinguishes an addiction from potentially excessive or problematic use is the loss of control over one's behavior. So what we'll also see in clinical context is that once individuals lose the control over the behaviors, they might know that actually the behavior is excessive, they want to stop it, but they actually can't. They realize they may need to speak to somebody who may be able to help them.
Do you know who is most susceptible to this?
I think what the current research evidence base shows is that there are a number of individuals who may be more susceptible to developing problems as a consequence of their social media use. And these users are very frequently females. So what we'll find is that females are much more likely to engage with social networking sites and social media potentially more excessively than males. Younger users appear to be at risk for developing addiction-related problems as well. And that may have to do with the fact that they may feel the pressure to keep updating their online status. For example, they may feel the pressure to have to upload pictures on their social media platforms, etc. So these, I think, are the main criteria. But you will also find that a number of personality traits have been linked to potentially excessive use. So we know, for example, that narcissists are much more likely to use social media in order to represent themselves in a better light, for example. We also know that people who are particularly extroverted use social media in order to increase their already big real-life social networks, whereas introverts also appear to use social media significantly more, but for other reasons, in order to enhance their social networks, which may in real life or in the offline world be smaller than online.
But why do you think that people do this? Why are they making this a substitution for a real-life conversation with a real-life friend in real time? Why do they sort of eschew their friends and their dinner conversations to pick up their phone?
I think there are a number of reasons for why people use social media, maybe in favor of actually engaging socially in the offline world. One of those reasons is the rewards that social media use offers in terms of the brain mechanisms involved in using social media. So every time somebody likes a post on Facebook, for example, you might get that little reward in your brain that's telling you, oh, that makes me feel happy, that makes me feel content, and that's the reason for why I'm going to repeat this, because I've got that little bit of happiness, that boost of happiness through engaging with social media. In addition to this, what we will find is that you have got significantly more control over your interactions online than you have over your interactions offline. So you have got the time to compile a response to somebody's social media post that may be in line with what it is that you want to say, that may be in line with the way that you would like to present yourself. Whereas in a real life conversation, there is a lack of control. So you really don't necessarily have the control over how you're going to react, what you're going to say. And so I think there are a number of reasons for why people feel a bit more comfortable engaging using social media rather than engaging in offline social conversations.
So what should we do about it?
When I'm being asked that question, then I often say actually use social media. And the reason for why I'm saying that is if you are giving yourself the time, let's say an hour in the morning and an hour in the evening to use social media, you're able to get it out of your system. And that may also allow you to free up all the rest of the time to do other things, to see people face to face, to engage with your working life, with your academic life, etc., without necessarily thinking, oh, I need to check my phone every 5 minutes. In addition to this, what I would recommend is to leave the phones to the side when you are in an actual social offline setting, when you are having dinner with your friends and family, for example, because research also suggests just simply having the phone on the table without actually using it is impacting how we're behaving.
France is currently considering banning mobile phone use across the school day. Sounds like quite a good idea then, based on what you're saying.
I wouldn't say that I'm particularly in favor of banning phones from schools altogether, because we are all using technology. Technology has become an integral element of our lives, and I think completely forbidding it isn't the right way to go. I think what we want to do as educators, as parents, as teachers, is to ensure that we advocate a use that is a conscious use, that is aware of the potential pitfalls of technology, but which is at the same time aware of the great benefits that technology use can offer us.
That was Daria Kus from Nottingham Trent University. And if you'd like to find out more about social media addiction, Daria's written a short article about the topic at nakedscientist.com/articles.
So far, we've dwelled on many of the downsides of social media, but there are also many positives, and University of Vermont statistician Chris Danforth is developing computer algorithms that he says can spot people with depression just by looking at the content and compositions of photographs that they're posting onto the social media platform Instagram. In tests, he's achieving up to a 70% pickup rate. Georgia had this report.
It's my lunch break and I've come to walk around Madingley Hall Gardens as it's a very nice view, even though it's slightly cold. And the hall is looking very magnificent in the winter sunlight. So I'm going to take a photo. What's the point of taking a photo if I'm the only one who sees it? So I better put it on all my social media accounts so all my friends know exactly what I'm doing. But am I giving away more than just what I'm up to?
There have been a number of studies in the last few years looking at aspects of our behavior that we reveal through social media. In particular, studies that we've been involved in have been looking at trying to assess someone's mental health from aspects of images they post to Instagram and messages they write on Twitter.
And how have you looked into this?
What we did was recruit individuals who had been diagnosed with depression by a psychiatrist and were active on social media at the time. And we asked them for access to their social media feed. So we compared pictures they took with pictures taken by a control group who had not been diagnosed with depression. What we found was that individuals who had been diagnosed with depression, their pictures tended to be bluer and darker and grayer. They tended to have less faces in them. And these results are consistent with what psychiatrists know about how depression affects people. It literally causes them to see the world with less color in it, and they spend less time in large groups of people and social interactions. And so while those findings weren't particularly surprising, what's really exciting about that particular study from our perspective is that when we restricted our computer model to only have access to pictures posted by people prior to the date that they were formally diagnosed, it still picked up on these differences. And that's an indication that we could be able to get individuals who are suffering from depression in front of a doctor sooner.
Oh, wow. So you could sort of quantify these pointers, like having blacker and bluer pictures, and these things appeared before people had actually got a clinical diagnosis.
That's right. Yes. And it's, the results, they're consistent with what people are finding looking at other sources of social media as well. So we looked in a separate study at depression and PTSD and identified predictors of those health states from words that people were using on Twitter and their behavior, sort of the frequency of their posts, how likely they were to include links in their posts. And there were indicators that there were differences well prior to the date that they were formally diagnosed. And so I think that the results of our study are promising, but they're really just a proof of concept. There's a small group of a few hundred people in each of these studies. And it's not clear that this would translate to sort of the average person using Instagram or Twitter. But the goal is to try and figure out how to leverage all of the information that we give our mobile phone about us, our tone of voice, the words we use, the people we communicate with. This sort of data, it's incredibly private, so if we can protect it, but yet at the same time give algorithms access to information that's predictive about our health state, we could be, connecting with our doctor sooner, for example. The doctors could have access to a lot more information than they would get from a typical, yearly checkup interview.
And do you see this being used by the social media companies themselves?
So certainly companies know a lot about you, even if you're not using it, just from what your friends are doing on the site. And I do expect that there are going to be situations where social media companies are selling advertising spots for people who are suffering from mental health problems, potentially without even intending to or realizing that they're doing so. So that's something that I think is really important right now, is that we start having a conversation with each other about how to protect this sort of data. This particular study was done by a few people with limited resources, but certainly if we could do it, then a company like Instagram or Facebook or Twitter, they could use this data to try and make money, and we'd like for them to use it to try and help us be happier and healthier.
I suppose that is a worry. People would be worried about their privacy, that people could see that they're depressed before maybe they know themselves.
Yeah, I think that we reveal a lot more about ourselves online with our sort of digital footprint than we're aware of. And part of doing research studies like this and communicating the results of the studies to people is to help educate the population about what it is that they need to be aware of when they're on the internet.
And is there a way the social media companies could use this information for good?
Sure. So, certainly Facebook and Instagram are active in trying to provide mental health resources to people who, for example, search for the word depression or use words that have been seen to be predictive of self-harm. They have teams working on trying to get individuals who are suffering from those problems access to people sooner. And that's a combination of artificial intelligence and actual people who are then called in to virtually try and address whatever's going on and maybe potentially dispatch police officers to attempt to rescue someone. And so companies are working on that sort of thing. Stepping back to the sort of the picture of public health, there are a number of other studies, some of which we've done, showing that things that you might like to quantify about how well a city or a society are functioning, those things can be inferred from the words that are used. If you look at particular geographic areas, we've shown, for example, that population scale health rankings, like the percentage of people who are obese or who suffer from diabetes, those things can be inferred from just the words that people use on Twitter. Well-being surveys that are done by Gallup can be inferred without asking any questions, simply by seeing how often people use happy and sad words in different states, for example, in the U.S. And so there are going to be applications for this sort of public health instrument building that people are going to develop.
So social media can be a force for good and bad, depending on how you use it. What's clear is it is a force to be reckoned with. Thanks to Chris Danforth and to all our other guests this week. That's Daria Koos, Sander van der Linden and Philip Powell.
And to finish, it's time for Question of the Week, where Heather Walk has been fishing for the answer to this deep-sea dilemma sent in by the Waite family.
Hello, Naked Scientists. We've just added a puppy to our family and we've noticed that he yawns a lot.
While we were watching Blue Planet 2 this week, that got us wondering.
Do fish yawn? Is there an aquatic equivalent?
Fishy. Luckily, we've got Ian Barber, an animal biologist at Nottingham Trent University, to talk us through this marine musing.
Well, it all depends on what we mean by yawn. Many fish do open their mouths very wide for periods of a few seconds at a time, which resembles a human yawn. Stickleback fish do this while raising their spines and flexing their body, which really does look like they're having a yawn and a stretch. Cool word, pandiculation. But we can't assume that just because fish sometimes open their mouths wide that they're yawning.
To understand if fish truly yawn, we need to understand what the function of yawning is.
Unfortunately, it turns out that this is one of the great unresolved mysteries of our time, with the most obvious explanation, that yawning increases oxygen supply in the blood and helps make us feel less tired, being largely discredited by experimental studies. The most convincing theory currently is that yawning serves to cool down the mammalian brain, which fatigues as it warms up. However, such a brain-cooling mechanism is unlikely to benefit fish since, as ectotherms, cold-blooded animals, their body temperature is controlled by that of their environment anyway. So if yawning turns out to be defined as a mechanism for cooling the brain, then no, fish do not and do not need to yawn.
So what are fish doing when they make those yawn-like mouth movements?
Well, for some fish, we know that mouth gaping is used in ritualised sexual, territorial or aggressive displays. Some fish can produce sounds through a variety of different mechanisms, and opening the mouth may allow those sounds to be directed at mates or rivals. Fish, of course, breathe through their gills, so if they need to increase the flow of oxygen to their tissues, they may also be able to do this by increasing the flow of water through their mouth and over their gills. Opening their mouth wide while swimming fast can have this effect, and this is how fish like mackerel and tuna satisfy the high oxygen demand of their tissues. And finally, some coral reef fish also gape as a signal to stimulate cleaner fish to begin cleaning them.
So we don't really know whether fish yawn or not, but coincidentally,
there is a fish called a yawning, Poromitra ossitans. It's a member of the family called the ridgehead fish, deep-water fish of the tropical Indo-Pacific zone, and it's a bit of an ugly brute.
Thanks, Ian. Next week, we'll be cooking up an answer to this culinary conundrum from Martin.
Why, when cooking fresh pasta or gnocchi, does it rise to the surface when it's ready? As far as I can see, the dough is solid, so I can't see how the density decreases. Thanks a lot for a great show.
What do you think? You can email chris@thenakedscientist.com, find us on Facebook, tweet @NakedScientist, or join in the debate on the forum. That's thenakedscientist.com/forum.
And I've learned a brand new word this week, that's pandiculation. And that brings us to the end of the programme. Thank you to Georgia for production. Join us next time when we're celebrating the science of Christmas, including how to untangle your Christmas lights. The Naked Scientist comes to you from Cambridge University and is supported by the STFC, the EPSLC and Rolls-Royce. I'm Chris Smith, and until next time, goodbye.